Hello class, my name is Nicholas Sierra and my partner is going to be Giovanni Aguilar. And for our final project, we ended up selecting the power output estimator. We had selected another one originally, but we ended up switching it up just so you guys are tracking. So for group 22 final project, first we're just going to describe what the combined cycle power plant is. So the combined cycle power plant produces energy in not one but two ways. First, it uses gas turbines that mixes air and fuel that is compressed, creating high amounts of energy inside the system, which drives the generator to produce electricity. Secondly, once the gas turbines release gas out of the generator through the exhaust, the heat release is then used for steam turbines that captures the heat and it uses it to boil water to produce steam. The steam is captured to help generate an additional generator that produces electricity. The combined cycle power is preferred over the single cycle due to it having more ways of producing energy and causing less harm to the environment. So we're going to do the second part of the project, which is explanatory data analysis. So what I ended up doing was I imported this file and just printed out the data as is. So as you can see, just looking at the file, you can notice real quick that it just looks like a whole bunch of letters and numbers. So I just wanted to make sure that this data was more clear to anybody viewing it. So the first thing I did was I ended up printing a header, which was describing what the data is. So it's the cycle power plant from 2006 to 2011. And then I ended up dropping the file in. And once the file was dropped, I ended up renaming these abbreviations to the actual name, which was the temperature, exhaust vacuum, ambient pressure, relative humidity, and electrical energy output. And then once I did that, the last thing I did was all the numbers in the file, I just made sure that they're all going to be floats just to avoid any errors. And as you can see, it has the cycle power plant from 2006 to 2011. And then all the numbers for each column is going to be a float. And then the abbreviations are more clear now. So the second part is model building, which is build a regression model for the estimated power output, PE, using 4 inputs. Access the model quality. Build the input data interface for using the model. Then using the model, determine projected total power output for 5 possible ambience parameters given in the table below. So in order to do the first 2 parts, we ended up importing the libraries, which was pandas, just to see the file. And then we ended up importing the linear regression, which is to view any algorithms that are going on, and then the train test split just to test the model, and then the mean square error just to make any predictions. So first thing, like always, is just reads the file. And since we are tracking the PE, what we ended up doing was we ended up making X as the AT, and then the V and AP and RH, and as X, and then Y is just going to be the PE, since that's the target that we're trying to see. So we ended up testing the data with the test split, and then the linear regression just to see the linear regression for the model, and then make any predictions using the test. And once we have that, we just ended up printing out the results for each of these values. The MSE ended up being 20.27, and then the model intercept ended up being 454, and the R square was 0.93. So for the rest of the presentation, Giovanni Aguilar is going to finish it up. Thank you.
Okay, here's a how to on my on how to on how to write a program for power how to build the input data interface for the power output predictor project. First off, we're gonna start off by importing the two necessary models and libraries that we're gonna have to use. Then we're gonna have to read our file, the ccpp.cvsv. And then for the next steps, we're gonna have to assign x and y values that are in the file. So, what is necessary for our model? Equal linear regression. We're gonna use the fit method, which uses x and y. It uses the relationship to x and y to learn and train our models. Then here we're gonna define predict power output with temperature, vacuum pressure, and humidity. They're all gonna have to be required user inputs, and they're all gonna have to be numbers, so we convert into float values. And then for input data, we gather all the user inputs and convert puts it into a data frame. So because our model expects it expects it to be in the same format as the trained data, so we need it to be in floats and all that. Same with the columns of AT, the AP and RH, so relative humidity and all that. And then for these two lines, we use the predictor method to feed the input data into the trained model that we made earlier to predict the energy power output. And finally, we just print out the output for the data. Oh, and for this side, where is it? Oh, for this code, we do the same thing. We import Panda, our necessary libraries. We read the file. We assign x and y values to the rows that are in the trained data in the file, and we load model equals linear regression. So we use the fit method for the correlation between x and y. And then for this part, we're gonna have to create a new data frame with each inputs. Each row represents a value of x, v, ap, or rh. And then here it's gonna we use a predict method to generate predictions that give us an array of the predicted values, which we print with the loop. And then finally, I guess this is the same thing. All this is all the same thing that I just described. And it's just gonna predict it within 2 decimal points. It uses the thing that creates a loop, and all that data turns out to the predicted power energy point with given values.